Welcome. In this particular demo, we're going to have a look at how we can handle input, touch-based input within our apps. In particular, we'll have a look at a single touch to get us going, and then we'll go on to look at how within Android we can handle multiple touch events. And this, for example, would occur whenever, if we have a game where we're using the two thumbs as controllers, then at any point in time we can have both thumbs touching the screen, so we'll have 2 points of input. But we'll work towards that. So let's start off first of all having a look at single touch, and we'll expand up from that particular one. Now we have a simple demo here, and we'll look at the code base behind it in a second. I've got an interface with an X and a Y and an area saying touch here. Now I could touch the screen, but I'm using the mouse in this particular bit. So when I do touch, and I've notionally pressed the mouse down, so I am touching the screen, it gives me my X coordinate. So over here in the top left hand corner it's 0, 0, and it goes down towards the bottom right as the lower coordinate. As I move around, and you can see me here clicking and moving in different ones, you see the different events occurring up at the top. So if I were to hold the mouse down, we get a down event, then I start it to move, so we're detecting that after that down event we've had a move commencing, and I let go, we get a move end, that I had started move and now ended moving, and we also get an up event. So there are some of the events that we want to be able to tease out. So we'll have a little look about how we can manage this. The particular class we're interested in is the single touch fragment. And it is a fragment. It's a fairly straightforward one, so we'll have a little look through what we have within it. We're creating a view, and we're inflating the interface that you've seen on the screen. So we had a sort of a touch area, a few labels at the top, nothing much more than that. And we're going to the text view, which is our touch area. We're retrieving it, and then we're saying for this particular component, the text view, we want to add in a touch listener. So we are interested in actually processing and getting any touch events that occur for that particular component. And we can do this for any component at all that we want to. We can add a non-touch listener to it. The particular on-touch listener that we're adding is going to be a class that we will define ourselves. Depending upon the complexity of the touch listener, you could put this in here as an anonymous inner class, but this is a touch listener which has a reasonable amount of code to it, so we've defined it as a separate class itself. Let's have a look at that class then. So it is a class single touch listener implements on touch listener. So we are a derived type, and for us it's just going to be able to handle a single touch. Within it, now there's not really a lot to this here. We'll have a look at, we've got one property, which is going to be the last motion event that occurred. And that's important. If we want to be able to recognize when we have a move finish, then we need to be able to check, well, what was the last event that happened before that in terms of a move actually starting. So motion events, we'll look through the different types. Actually, we'll look at them now. In terms of motion events, you can see there are quite a few different events that are defined within it. We're only going to look at a few simple ones. You'll see this underneath. We've got an overridden method. So this is the key method that all of our on-touch listeners declare. It's a public boolean on touch. And that's the one that gets to be called as a callback method anytime there is a touch event happening. So we want to look at that. But before we do it, just jump down to the middle or the bottom of the file. You can see here we're declaring a string builder. We've got a method display touch position, which will display it on the screen, and display event, which will update the event log containing the information. So what's at the bottom of the file is just simply logging the touch events that occur. So everything of interest happens within this particular on-touch callback. A few things that we do. So we will, we're going to have mention this first. We return a Boolean variable. If we consume, notionally we process and we say, yes, we've taken that touch event and we've done everything we want to do with it, we've notionally consumed it, and we can then return that through the return of this particular method here. If we're looking at it and we only partially used it or we weren't interested in it, then we could return and say, no, we haven't done anything with it, and that would then indicate that it should be passed on to the next OnTouch handler that's available for it to manage. Other things that are passed in, we have the view component. Now, any view, anything that's visible on the screen, potentially can receive touch events. So this lets us know which is the component that received that touch event, and that will be the text view that we got set up in this particular demo. We then actually have the event itself. It's a type motion event. This will embed all of the relevant information about that particular touch event, and that's what we're going to be mostly querying. Because we know that we only have one thing here that we can touch, and because we've only associated this handler with that one component, we're effectively ignoring the view. If you did have multiple components you could touch, and it's probably not going to be the case for our games, and you had one event handler handling it, then within that you could check to see, well, which thing received the touch, and then process that correspondingly. So what do we have then? Let's have a look down here. At the top, we are getting out information about the event. So we're calling a method getActionMasked. Rather curious method. It's maybe not as clearly named as it could be, but this returns, if you like, the simple event. What is the basic event that happened within it? And it hints at the fact that for a touch event, it can be complex. You could have multiple fingers touching and moving about, all as part of the same event. This getActionMasked simply returns, okay, well, what happened? What is the most salient thing that happened recently? And that is what is extracted out of it. We get an event type, so it's enumerated type. It will let us work out later on down there, well, what actually was that event. In terms of the location, this is on screen coordinates relative to that particular component. So the top left of the component, the view, is 0, 0, and it goes on down. We can get the X and get the Y of it, and then process those as we wish. We're getting out from this here, it's a float value. So it is, depending on the screen, potentially capable of providing a ranged value at a resolution greater than a pixel. It just depends on your device. Once we have that, we're going to call our displayed touch position. So that just simply says, okay, there's the X and the Y. And the last bit of interesting code for this is that we check to see what type of event do we have. Now, we're only logging things out if we have a change in event type. If I didn't have this particular line in, and I always logged it out, then as soon as I clicked the mouse down and moved, you'd have a whole stream of move events being triggered. So it basically wants every single frame within the game. But here I'm only interested, okay, do we have a change in the type of event, just by way of not swamping the text field. So if we do have a change, if it's different than the one we had last time around, we're checking to see, well, okay, let's switch the event type. And we're looking here at the motion events. So this is our collection. And the ones that we're interested in are action down. This is corresponding to a press happening on the keyboard. So we've now actually have an action or a press occurring, in which case we display it out. Action move is where we have a press, and then that continual point of pressure, it starts moving across the screen. And action up, we do a little check here to see, okay, if the last event was a move, so we were moving on the previous frame, and in this particular one we've now lifted our finger up, then that constitutes the end of the action, and we say that we've now ended our move. And alongside that we also say that it has an up event. And this gets into the fact that if I were to press down and then press up without moving it, I only want to see my down and up events occurring. But if I were to press down to start moving it around, then whenever I release, I get the end of my move, and I also get an up event occurring. So it comes into how we interpret the different components. And that's it. So it's a fairly simple piece of code where you touch, you move, it detects and displays the location at the top. You can see there is some fractional components there, and it will give us an indication of the event that has happened. Simple, but it's fairly straightforward. Now let's have a look at multiple touch events. This is on our multi-touch test fragment. This is a little bit more complex. We used single touch because it sets out some of the groundwork, which we can then enrich or make slightly more complex when we're looking at multi-touch events. For most of our games, we will want to support multi-touch. So it's important that we do sort of get our head around this. By way of the demo, and you can run this if you want, it doesn't work particularly well on an emulator, because the emulators, at least the current ones, do not support multiple touch events. So I can only record this as a single touch event. And you can see in the interface here, I'm updating the location on the screen of the touch event, but all of the other ones are 0. So I could, if I was able to put down more than one finger, have multiple events occurring. And you can see over here, I'm also saying touch event, the ID of 0, what is happening, move start, move up, move down. So functionally, it's exactly the same as the previous one, except if we have an emulator or device that supports multiple touch, then we can touch more than once and get different values appearing up within this. So let's have a look at the code on this here. Most of it is very much the same. We're creating our view, we're loading in the UI that we're using in this particular case. We're saying, okay, we want to add in a touch listener. Again, we're defining it within a class. Within this particular class here, again, it implements onTouchListener. We've got some variables here at the top, we'll come back to in a second. We've got our onTouch method, which again we'll come back to in a second. And down at the bottom we have our in this case, 2 string builders, method for displaying the event locations and one for displaying the events that have occurred. So all of the things we're interested in are really up here in terms of what it is we have defined and our onTouch listener. Now, this is where it maybe gets slightly confusing. If we're thinking about multi-touch, we will be dealing with what are known as pointer IDs, and they are one of the core mechanisms whereby we will be able to process multiple touches. You can see here we're doing event get pointer ID, and a lot of the processing down here is using the pointer ID. So what is a pointer ID? The use of the word pointer is slightly confusing in this particular context. From a programmer's perspective, a pointer can be something that points to a piece of data in memory. It can be a pointer variable. A pointer, from a, if you like, a human perspective, could also be something that you point to the screen with. It could be a digit, it could be a finger. So pointer has not necessarily an obvious interpretation in this case. As it stands, what we say here, what we mean here when we say pointer, is a pointer, a piece, a touch on the screen. So think of pointer here as a digit, as a finger, something that is actually pointing at and touching the screen. Why does this get slightly confusing? Let me show you an example of this then. So here we have our tablet. We're assuming here we have a touch event that has occurred. And if I were to go to my event and look inside it, I can call my getPointerCount method, which I do have. It would say there is one point of contact on the screen. There's one pointer to the screen. And it would give me the pointer ID. For example, this is your pointer ID 1. And it would give me the X and Y locations, 100, 400 down. Now, if I then, because it's multi-touch, put down a second point of contact, so now I have 2. If I go to my event and the event is passed in, it contains information about all of the touch events that have occurred. So I say, okay, how many pointers do we have within this? It would tell me there's 2 pointers. In other words, there's 2 points of contact on the screen. If I were to query them, I would find I have a pointer 1. This is the same one I had before, and assume it hasn't moved to the same location. And I now have a pointer with an ID of 2, say 300 across, 200 down for that particular component. Now, I want you to think, what happens? I've got 2 points of contact at the minute. So I pressed this first, then I went on and I pressed that. If I release my finger from this one here, what am I going to find within the event? Well, if I do that, so in this case here, I'm back to one point of contact. I say, okay, how many pointers do I have? It's going to tell me there's only one. But if I go and look at that pointer, it's going to tell me the pointer ID is 2 and the particular location for it. So whenever you have a pointer, something touching the screen, like a finger, it is given an ID, and it keeps that ID throughout all of its life. So as long as that thing is touching the screen, it's going to have the same ID. If I came along and I then touched the screen again, so I've still got my, what happened to be my second point of contact, but now I've put down the third one in terms of my sequence. I say, how many points of contact I have? 2 of them. Well, what are the pointer IDs? In this case, it's going to tell me, okay, here you have one over here. This is the long-standing one. It's got a pointer ID of 2, and it's kept that throughout all of its history. There's its location. And here's the new one. And it gives it the first free pointer ID. And because we don't have a pointer ID of 1 on the screen, it is assigned a value of 1, and then it becomes pointer ID 1, and it has its particular location. So this is the key mechanism whereby we will manage this. Anytime we touch the screen, that touch, and as long as that touch persists, will have a fixed, constant pointer ID. And that's going to be the core mechanism whereby we manage and recognize and look after and differentiate and distinguish between our events. Right, so let's have a look at what we have within this class. I'm declaring a variable up here for the maximum number of simultaneous events that we want to support at a point in time, 20. So it assumes that all of your fingers and your thumbs are pushing against the screen if you want to. We're declaring here arrays, so each pointer, each point of contact can have an event associated with it, so it could be moving, it could be moved up, whatever is going to be the case, and it's also going to have an on-screen location relative to the top left component of that view. Got the same method, the on-touch method, and what do we have within? So we've got a few things happening within here. Because we want to display for this particular event that's just happened, well, what has happened? What was the most recent meaningful or significant event that's happened, irrespective of how many other events we had going on in the past? We call our event getActionMasked, and it'll return out, okay, well, in this one here it was pointer ID 2, it's now being pushed down, for example. If we want to get the ID of that particular event, so to work out, okay, well, what point of touch was responsible for that event? So for example, if we had several fingers touching the keyboard and we lifted up one of them, so the event is going to be an action up, something has left the screen. If we want to work out, well, what has left the screen, which of our pointers has left the screen, then this is how we can find out the ID. We can go to the event, we can say get pointer ID. So it's going to tell us an ID, and we're passing in here the event get action index. Now, it's a fairly standard formulation here. Effectively, our motion event has a lot of things maybe that has occurred within it. I may be moving my fingers about, different things are happening, but the action, the index of the action that occurred is this one here. So this gets me out the index of the action, and I then say, okay, let me go to and work out what pointer was associated with that particular action at that index. Can be a slightly confusing way because it's basically a double indirection, but nonetheless that's the way that it works. What we have down here then is where we are checking and updating on screen, well, what type of event has occurred. So we're switching the last action type for this pointer to see what it was doing in the previous frame. If it's different, then we're either going to say, oh, it's now being moved down, or we've got a move start, or a move up, or an end, a move end or an up. So this is the same types of things are being displayed as in the single touch. But you'll notice here that the cases, we have a few other things. We've got action down, which we had before. Now we've got an action pointer down, which is new. Action move, we had that before. Action up, we had that before. Action pointer up, that's a new one. So what are these new cases that are coming in? Arguably, it was good design, but nonetheless, this is the way that they did it. So action down, it always occurs for the first pointer, the first finger that touches the screen. So if nothing's been touching it, and I then push something down for the first time, it is returned as an action down motion event. That's what happens. The action pointer down, this one happens where I already have a point of contact, one or more, and a new point of contact comes into the screen. So it occurs alongside existing points of contact. Then the motion event here is an action pointer down. Likewise with up, an action pointer up. If I have several points of contact in the screen and I release one of them, so I still have several touching, it's an action pointer up. And if I only have one point of contact remaining with the screen and I release that, then it's an action up. Swings and roundabouts, I mean, in most cases you can simply just trigger the same action on both of these cases as we're doing here. If you do need to differentiate between it, you can do that. But at the bottom is also useful. It's the type of thing you'll probably be doing quite frequently within the game. Here's another way of going through and looking, okay, what touch points do we have? We're saying here for event get pointer count. So this is the one that returns the number of points of contact that we have. And we're going to iterate through each of those pointers. Now, important thing to realize here. This is obviously going to be an array. Get the number of pointers, and I'm getting pointer ID and get the index out of it. If I have 2 points of contact, and this was the example over here, 1, 2, I'm not guaranteed that pointer index 0 here is going to correspond to the first pointer event, and pointer index 1 is going to correspond to the second pointer event. You've no guarantees over how the events will be, the pointer IDs will be structured within the event. You simply can work out how many they are. This is where the second line comes in then. If we do want to work out the pointer ID for a particular index here, we need to go to the event and get the pointer ID for that index. So we can say, okay, yes, I know there's 2 pointers events that have occurred at the minute. Let me go and get my pointer ID, and from that I can retrieve what particular index of that event actually occurred. It makes sense if you think about it. Sake of argument, I could touch 5 fingers down on the screen and then release 3 of them. Now let's assume that there's only 2 that are left, but the 2 that are left are the ones I put down on the screen latest when I was putting down the first 5. So 1, 2, 3, 4, 5, then I release 1, 2, 3. So even though I'm going to have 2 pointer counts, or a pointer count of 2, the pointer IDs are likely to be 4 and 5, because these are ones that occurred rather later. There was other events alongside them. So there's a reason for doing that. Getting at the pointer ID, I can then go and update its X and its Y position, and then display those on the screen. And that is it. Again, it's a reasonably small chunk of code. The only difficult bit in this, and it is only difficult until you get your head around it, is being able to differentiate between a point having an identity that persists through it, and then whenever we get our event, we have a number of sort of events or pointers that have occurred within it, but we need to be careful about getting the ID associated with each of those. If you can do that, then you can process multiple touch events within the game. This is all we need by way of basic functionality. Obviously within the game, that the touch events that we have, they may be as a thumb controller, you may be looking at gestural control, but this is your underlying basis whereby you can track that movement. How you interpret that movement to provide an input, obviously is going to depend upon the type of game that you are creating.